Hello sir, I am Prashant Mari. This is the IFE2 Activity 2 and I am from CFE department. My serial number is 59. Here I am explaining the critical path using the forward path and backward path computation. This is the example or a project network where we have some activities A, B, C, D to J and some preceding activities which are performed before that activity and the duration of that activities. First we try to create network diagram. So first we create one network diagram. Here A is the starting node. A is the starting activity because there is no any previous activity behind A. So here A is the first activity. So we can draw this activity as this is our first node and suppose this is the activity A. Then we see that B, C and D three activities are performed after A. So after the A we have to create one node and after that node we have to create three activities. Suppose this is the activity D, this is the activity B and this is the activity C. Then after the activity C there is the activity D which is performing after activity C. So we create here one node and then we create some activity that is E. Here we don't know where the E is after the completion where the E is goes. So we kept is at it, and this as it is, and we try to generate our next activity in network diagram. After the E there is activity F which is after D activity. So here we create one node and after the D we create one activity that is F. Then there is a J activity which is performed after the B activity. So we here create one node and we create one activity G. Then after the G there is a I activity which is performed E and H. So we don't know where is the H activity. So there is H here. See, there is the H activity which is the after J activity. So we create one node and we create one activity that is H activity. Now here is one problem, that is I activity which is performed after E and H. So we have to connect that E activity to the node of H, the node after the H activity. So we connect this activity with this node, and then after these two activity there is the I activity, activity I. Now here J activity which is performed after F activity. Then where is the F activity? Where F activity is here. So we create one node here and after the F activity there is a J activity. So we create here one node and we connect J activity with this and we named it that J. So here the network diagram is complete, which starts with one single node and which is end at one single node. Now we calculate the forward path and backward path. For that we have to write the values of that particular activities. So A is a 1, then B is a 4, C is a 3, then D is a 4, F is 2, E activity has value 3, then G activity has value 1, then H activity has value 4, then I activity has value 2 and J activity has value also 2. Now we here calculate the critical path first. So there, how many paths are there available? There are three paths. See, A, D, F, G, A, D, F, J. Then second path is A, B, G, H, I, and third path is A, C, E, I. So there are three paths. We write down that path. That is, first is A, D, F, J, which has weight 1 plus 4 plus 2 plus 2, which is equal to 9. second path is A, B, G, H and I, which has weight 1, 4 plus 1, 4 plus 1, 2, that is equal to 12. And third is A, C, E, I, which has weight 1 plus 3 plus 3 plus 2, that is equal to 9. So the critical path is this path because the weight of this path is highest. So critical path is A to B, B to G, G to H, H to I, and duration is 12. Now this is the traditional way to find the critical path. We can also find the path using forward and backward path computation. For that we have to create some boxes at every node. See, this is the boxes at every node. Now here we start this with 0 and we at the junction we put the highest value of that root. So in this junction there is only one value, this is 1. Now 1 plus 4 we can write here 5. 5 plus 2 we can write here 7. Now here we can direct not write the 7 plus 2 9 because here is a junction. There is another two ways which are coming here. So we kept it as it is. We try to write here, that is 1 plus 4 is equal to 5. 5 plus 1, that is 6. 6 plus 4, that is, we have to write here 10, but there is also a junction and there is another path, so we kept it as it is. Then here 1 plus 3 is 4 and 4 plus 3 is 7. Now 7 is less than 10, so we can write here 10 because this path gives us the 10 value and this path gives us the 7 value. So we write the 10 value, which is a higher value. Then 10 plus 2, here we can write 12 or 7 plus 2, 9. But 9 is a small number and 12 is a greater number, so we can write here 12, which is a greater number. Now this is the calculation of forward path. Now for the backward path, first we have to write here 12, then we have to minus the value and write that less value at the junction. Now 12 minus 2, that is 10. Here 12 minus 2, that is 10. Now here 10 minus 2, that is 8. Now here is a junction, so we cannot write direct value because there are three paths. So we try to understand what is their path. Then 10 minus 4, there is a 6, we can write here 6. 6 minus 1, there is the 5. And 5 minus 4, we can write here 1, but there is another path, we try to get the value of that path also. Then 10 minus 3, there is a 7. 7 minus 3, 4. Now 4 is a greater number and 1 is a smaller number. But in backward path we have to write the smaller number. So we write here 1 and 1 minus 1, there is a 0. So the number which have identical figures, the node which have identical figures, this is our critical path. See, 0 0, 1 1, 5 5, 6 6, 10 10, 12 12. So this is our critical path, and that's all.